Hello, I hope that we are all perfectly fine. I hope that we are all doing so well. I hope that we are all perfectly fine. All right, let me just share the video a bit. Hello, evening, guys. I hope that we are all doing so well. I hope that we are all doing very well. I hope that we are doing so perfectly fine. Right, I've seen about 3 people have joined. How are we, guys? 14 people have joined, right? How are we, guys? Jemima, how are you? And others who are still coming, I hope that we are perfectly okay. I am very much fine. How about you? I am very much fine. Christabel, Cornelius, you were waiting for me, right? Hmm? You were waiting for me, right? Christabel, Cornelius, you were waiting for me, right? Yeah. All right. Interesting, guys. All right. Interesting. Oh, missed you too. All right. So now here, guys, thank you. I hope that let us get our graph papers, guys. Let us get our graph papers. So I hope our graph papers are very much available, guys. Take note that in physics we do plot. Huh? Mhm. You have you have to put that in mind. Okay. I hope our graph papers are very much available, guys. I hope so. How many have graph papers? Make sure that you do as wise, remove one graph paper, then also make sure that you do have a pencil and also a calculator. Right. And I know concerning the part of Christabel and Cornelius and also others, we were together in the afternoon when we were talking about what? When we were talking about radioactivity. Yes, including Karen. Okay. How was the lesson, guys? Karen and others who joined in the, it was in the afternoon, yeah? If I'm not mistaken, right? Yeah, it was in the afternoon. How was the lesson, guys? How was the lesson? How was the lesson? How was the lesson? How was it to all those who joined? All right. Thank you. Blessings. It was good, Karen, right? Yes. Cornelius, how was the lesson on radioactivity? So powerful, right? Yeah, great and very interesting. Yes, it was so powerful. So now, guys, we are going to answer this question. Okay, we are going to answer now this question. Guys, we already did the introduction part when it comes to radioactivity. We did the introduction part. Okay? We did the introduction part and also, okay, that's how it was. So here the question, this one, guys, take note that radioactivity also comes in section C. Okay, it also comes in section what? C. Yes, but you can simply check the video still available. You can watch at night. Okay, you can still check the video. It's still available here. I haven't removed it. Okay, guys, have we seen how the question is? I hope it's way too visible enough. I hope we can see the table and also the numbers inside. Yes. Okay, interesting, guys. Now we have question A. Okay, we have question A. Thank you very much. Thank you. So we have question A, all right? So we do have question A. Here we do have question A. Then question A here says, state the nature of alpha emissions and beta emissions. Guys, the question reads, state the nature of alpha emissions and beta emissions. What is the answer here, guys? They're saying, state the nature of alpha emissions and beta emissions. What are the answers here? We did this part. Cornelius and others who were with me in the afternoon. What is the nature of alpha emissions and beta emissions? Mhm. Mhm. State the nature of alpha emissions and beta emissions. Okay, so the nature here in this case is more like just the definition. They're simply asking you to come up with a what? Okay, so Cornelius is saying, sir, alpha, it is helium. You should be writing very well, guys. Alpha, it is helium, and beta. No, they're not saying beta. Okay, they're saying beta. Okay, I thought it was gamma, right? And beta is electromagnetic wave. Are you sure? Are you sure? Are you sure beta is an electromagnetic wave? Are you sure? Okay, Christabel saying alpha emission is the helium nucleus and beta is the fast moving electron. Perfect. Okay. An alpha emission, like what we said, is a helium nucleus, while a beta emission is what? Is a fast moving electron. Okay. So here we have alpha, an alpha emission. So the nature is more like just they're asking you the definition. Okay. So here, Shadrach, how are you? Alpha emission, like what we said, alpha emission is a helium what? Is a helium nucleus. So is a helium nucleus. Like this. Then now since here they're saying we should state the alpha and also the beta emission. So we can say, okay, you can say wow, okay? We can say wow, wow beta, all right? Wow beta emission, okay? So wow beta emission, wow beta emission is what? Wow beta emission is a fast moving what? Is a fast moving electron. Is a fast moving what? Electron. All right. So to all those who were with me in the afternoon, they know what I'm talking about here. There's a link, guys. To all those who haven't watched the live session in the afternoon, go ahead and watch that live session. All right. Because as for now, we are just answering the questions from that lesson. All right. So here we are not wasting time in terms of going back. We're just going directly to the question because of time, because we have many things to look at. So here, guys, perfect, guys. Yes, and Cornelius, please, whenever you are writing, make sure that you put your heart in a very good what place or other side, right? Make sure that you stay calm. Okay, so yes, Karen, is the helium nucleus while beta is a fast moving electron. That's perfect, yeah. Okay, Theoma, how are you? Then now we move here. Hey, before we even move, guys, before we go to the other question, um, who can give me one difference between alpha emissions and also beta emission? Okay, give one difference between alpha emissions and beta emissions. Who can give me one difference? Who can give me one difference between alpha emissions and beta emission? Yes, guys. Who can give me one difference? Mhm, mhm. Yes. Who can give me one difference between alpha emissions and beta emissions? So urines, okay, saying beta is negative while alpha is positive. You know what? This is science, guys. You should be presenting your answer very well, okay? This is science, okay? You cannot just say beta is negative, all right? You cannot just say beta is negative while alpha is positive. No, positive what? Negative what? So make sure that your answer is in a very good what? Let me say way, or rather, okay, Alaska. Is this the same Alaska you know, who normally come for physical tuitions here? Okay. Yes, I am still on this question asking you, state one different, okay, give one difference, all right? Give one difference between alpha emissions and beta emission. Who can give me one difference? So Karen saying alpha is a positive charge while beta is a negative. That's how one can answer. All right? That's how you can answer. Don't just say positive. Oh wow, it's negative. No, guys, make sure that you answer correctly. All right? Make sure that you do so. Okay? So Karen saying alpha is a positive charge while beta is a negative charge. That's perfect, guys. Then Christabel also saying alpha emission is stopped by a paper. Perfect. While beta is stopped by aluminium. That's perfect, guys. Then alpha can be deflected by a sheet of paper while beta can be yes. Perfect. You understood, guys? Okay. Perfect, Kanal. Now we can move. Okay, perfect. We can move. Now here the question says a sample of a radioactive material produced the following results when its emission was measured at a fixed distance. So here they're saying there was a sample of a radioactive material produced the following results when its emission was measured at a what? A fixed distance. So here also Janet saying alpha particles have a plus one. Wow, better. You should mention, all right? Because I asked the difference. Don't just say plus one, then negative one. No, no, no. You say it has a positive charge while the beta particle has a negative charge. Don't write those plus one, okay? Make sure that you write in a sentence form. All right. This is science, guys. All right. Respect science. Also, Mace is saying alpha it has a positive charge while beta is has. Guys, it, it is has. Is the English there correct? Okay, perfect. Now, guys. So here, question B. A sample of a radioactive material produced the following results when its emission was measured at a fixed distance. Then now here, we do have a table which shows these results, okay? We also have this part, okay? We do have this diagram which shows the what? The results, okay? Now here, guys, on top, we have count rate in minutes. Then we do have these numbers. We have 490, we have 310, we have 190, we have 118, we have 82. Then time and the slash minute, we have 0, we have 15, we have 30, we have 45, then we have what? 60. Then now here the question says plot a graph of count rate, which is y. So they're simply asking you that the first part, the count rate, all right? This count rate must be on the y-axis. Then now on the x-axis, there must be time. It's more like this first column, which we are seeing, it is the y-axis. Then now the second, let me say the second box here, which is down in series, this is x-axis. So when you see a box in physics, okay, when you see a box like this in physics. So the first box means y-axis, then the last box simply means x-axis. So when we go against, it's x. So the first thing is y, then which goes after now against it, it's x. Then we do have also the last question here, which says we should do what? We should define the term half-life. Now, guys, before we do anything, we have to understand the rules of the what? Of the graph. It is very much essential for you that you do what? You know the rules of the what? Of the graph. So here, guys, the first key thing, what are you going to do? Make sure that on the graph paper, you write your name, your examination number, okay? It is very much essential. Those things, they must be written, all right? So here, what are we going to do? Let me try to do this so that it's way too clear enough. Okay, I hope, okay, let us do this. It will be way too clear enough. Yeah. Then now here, we are going to do this. Guys, this is the graph paper, you see? So this is the graph paper, guys. This is my graph paper. This is my graph paper. So now here, guys, there are some certain key things that you have to do before you even start what? Plotting. Certain key stuffs that you have to do before you even start what? Plotting, guys. Okay. Now here, guys, this is the graph paper. You have seen it. So make sure that you write your examination number very well. The graph paper which you will be given as for tomorrow, it will have the examination number, then also some other things. But this one, I've just gotten it, okay, from someone, okay? So here, the first key thing that you have to do, you do this. Whenever you are handling graph questions, what should you do? You do this, the first key thing. You see, guys, this box which you are seeing, you see, this box which you are seeing, make sure that you also write it on the graph paper, okay? This box which you are seeing, you just copy and paste exactly the way it is. You also write it on the graph paper, okay? So what are you going to do? So get your ruler. You get your ruler very well. So what are you going to do? At least it must be at the corner, okay? At the corner. So make sure that you write it what? Neatly. At least at the corner. So you do as wise. Make sure you get your ruler. Guys, use a pencil. As for me, I am using a pen here so that it's way too easy for you to do what? To see. Because if I use a pencil here, you won't be seeing. Okay? You won't be what? Seeing. So make sure that you draw a box just at the corner on your right hand side, all right? On top of your right hand side. This is what you do. Okay? Make sure that you draw a what? You draw a box. This is the question which you are answering. Draw the box at the uh, uh, right hand side of your graph paper, of the same graph paper. Okay, you do as wise. Okay, neatly. Okay, do it neatly. You see the way it is, ka? You see here it's written what? Count rate slash minute. So make sure that you write it at the corner. Then you write count rate slash minute. You see, ka? Like this. See? This is how you're going to do it. Then now here we have time. We have time slash minute. Like this. This is how you're going to do it. You see, ka? Then now get your ruler. Make sure just you just copy it, write it at the corner. Why am I doing this? Because now it will be way too easy for you to start what? Plotting without you now, let me say, going too much or flipping the paper too much in order for you to see the digits. Because we want to make our work way too simple here, or way too easy. We want our work to be way too simple. Then do as wise. Make sure that you count the number of boxes which contains or which has numbers. So how many are they? 1, 2, 3, 4, then 5. Make sure that there are 5 boxes. Okay, you do as wise. So make sure that there are 5. So here 1. Okay, also the other box, we have 2. Then now here, which is number 3. Then the last one, which I can say 1, 2, 3, which means 4, 5. Perfect now. Like this. Perfect, perfect. All right. So here, after doing this now, copy and paste the numbers inside. All right. You see, we are 490. You see? So we are 490. Copy it. Then now we also have 0, 15 down, 0, 15, like this. Then also we do have 310. We do have 310, you see? And also we do have what? 190. Also we do have what? We do have 30. We do have 30 here down, and also 45. Okay. Then also we are having what? 118. Then we are also having 82. And also we are having 60. Okay. Also having 60. All right. So these are some of the key things that we do here. We do have here. All right. So this is the first key thing that you must do, guys. This is the first key thing that you must what? You must do. Okay. This is the first key thing that you must what? You must do. Okay. So after writing this now, what are you going to do? After writing this box, now you can go ahead in terms of writing the title. Take note, guys, here. They're saying what? Here. The question. Plot a graph of count rate against time. Okay. So this is your title, guys. Make sure that you write your title. So the same question here. Okay, they're saying plot a graph of what? Count rate. So what they are talking about, these things, all right? Count rate against time. That's your title. Okay, make sure that you do as wise. You say, you can write your title in capital letters so that it's way too visible. You say in between, guys, like the way we normally do in English language, all right? You say count, okay, you say count rate. You see, in capital letters, you write your what? Your title clearly, okay? So count rate, okay, count rate. Forget about writing the y-axis and the what, just go ahead saying count rate against what? Time. So count rate, just say against what? Against time, like this. You see? So count rate against what? Time. That's what we are writing about. So once they say plot the graph of this and that, go ahead, copy and paste. This is the what? This is the title. Okay. So draw first the box, then now write the what? Then write the title like this. Okay, guys, is it clear? Is it clear when it comes to the part of drawing the box? Then after the box, then now we write the title. Is it clear? Is it clear here? Can we manage? Is it clear on this part? Perfect. So Vope saying it's clear. So that's what you should do even tomorrow when you get a what? A graph paper. Make sure that you get the graph paper, it will be inside the what? The answer, the question paper. Okay. So that's what you do. So the first key thing, write the box at the corner, then write the what? The title. Okay. So it's very much important. Okay. So where are we supposed to write? Here. Upon just writing, upon just making sure that you copy and paste this box, then just down like here. The way I am doing here, this is how you should do it. Okay. The way I am doing, make sure that your title is in between, not at the corner as if it's address, all right? Make sure that it's in between. Like this, this is what you should do. Gotten it, ka? Perfect, guys. Yes, the way I'm doing is that's how you should do it. All right. So here, guys, what should we do? We should get now a ruler. So get a ruler. So all the graphs in physics are written like this. This is how you start. Make sure that you draw the box at the corner. Then now write the title. Then now you do like all the graphs in physics. That's how they go about it. all the graphs. Okay, once they just say plot a graph, this is how you get to do what? To present your work. Okay, because it will be way too easy for you now to start plotting. Okay, because you have all the numbers already here without you doing this, without you now checking on the paper. Okay, it will be way too simple. Then now, guys, what are you supposed to do? Here, check, guys. Have we seen this first line of boxes? Guys, these boxes, have we seen? Okay, okay. Have you seen? Have you seen this line of boxes, guys? This first part of the boxes where I have put my pen. Okay, where I've put my pen. Have you seen? Have you seen? Okay. You can use a pen whenever you are writing a title, but when it comes to this box thing, use a pencil. Okay. Use a pencil whenever you are drawing this box and also the what? The graph. Me, I am using a pen here so that you see, because if I start using a pencil, you won't see. Okay. Because of the camera thingy and the lighting here, you won't see. Okay. So use a pencil, but for writing the title, you can use a what? A pen. That's what you can do. Guys, you must also let the graph breathe. Also, don't forget, guys, to let the graph breathe. It must breathe. Guys, do you know that the graph must breathe? Ka? It is not only in biology whereby we normally say characteristics must breathe, they must undergo this and that. Also, a graph must breathe. Do you know, guys, that a graph must also breathe? Yes. So in physics, I will guide you at last. I will guide you at last on how to handle it. Okay. On how to answer physics in an exam. I will guide you. Guys, do you know that a graph must breathe? Yes, it must breathe. So let us now make our graph to start breathing. So this first part, so get your ruler, okay? So get your ruler, okay? Get your ruler. These boxes which you are seeing, huh? So these boxes which we are seeing. So these first boxes, they must breathe. They must breathe, all right? So what are you going to do? So get your ruler. You start from here. That's where now you're going to start from, okay? You do like this, okay? Draw a straight line. Make sure that you put your ruler correctly. Okay, make sure that it's way too visible enough. Guys, use a pencil. But as for me, I'm using a pen here so that it's way too clear. This is your what? This is your y-axis. You see, ka? You must not start drawing, you must not draw your line from this line because the numbers won't fit here. So make sure let this part, let these boxes breathe so that the numbers will be way too visible for you to start plotting. I hope something has been grasped here, guys. So let these first boxes breathe. They are human beings, all right? All right? So make sure that you do as wise. So make sure that you continue with the line, continue with it. Now, guys, check. Now down, I'm moving down now. Here, you see, I am moving down. These boxes also which are down here, they must breathe. You see, the boxes which are down here, they must breathe. They must breathe. So get your ruler, then 10, 10, 10, 10, 10, like this. Okay? 10 as well. So here at the corner, you 10. Okay? Make sure that you 10. 10, guys. 10. This is what you should do. Okay? So as for tomorrow, make sure that you do these questions fast, all right? So that you'll be able to do other questions. Okay? You see, so this is how you get to do them. So here, this is the what? The X what? Axis. This is how you get to do them. You see, this is how you get to do them. Okay? Is it clear, guys? Is it clear? On this part, is it clear? When it comes to this part of coming up with the box at the corner, the title, then letting these lines, they do breathe. Okay, I hope this part is way too clear and way too straightforward and way too straightforward. I hope this part is clear and way too straightforward, way too straightforward. All right. And make sure what I can simply advise you also, start practicing. If you do have a graph paper, start doing what I'm doing. Okay. If you do have a graph paper at home, start doing this. Okay. Let us learn together. Okay. Make sure that at home you are also doing the same thing. Okay. So that you are practicing, guys. Practice makes what? Perfect. Make sure that you do as wise, because practice makes what? Perfect. That's what you have to know. Okay. Now let us start. Here, if you check, guys, we do have what? The count rate. So this is the what? The y-axis. So the first box which you see, it is the y-axis. Then this box, it is the x-axis. So what are you going to do here? Here, the y-axis is the what? Is the count rate. What are you going to do? You do this. You write here count rate. This is where the y-axis is. Make sure that you write what? Count rate. This is what you should do, slash minute. This is how you should do what? Present your work. Like this. So you write count rate slash minute. Like this. Also here you do the same thing. Don't forget, guys, even down, time slash minute. You come down, you come down. Okay? So you write a time. You see down here, guys, time like this slash minute. This is how you get to present your work. You see, huh? This is how you get to present your work. Okay, this is how you get to present your work. Okay, so here, guys, what are we supposed to do? Now, guys, if you check here, we have on the y-axis, we do have these numbers which are jumbled. Okay, and it's always, guys, let me tell you this. When it comes to plotting, it's like always, all right? In the y-axis, they are going to jumble the numbers, okay? These numbers will be jumbled. If you check, they are saying 490, then also they are saying what? They are also saying 310, and also they are saying what? 190. These numbers are jumbled, okay? And us, whenever it comes to plotting, we must plot them, let me say, in a very what? Let me say, chronological way, okay? And also we have 82. So these numbers are jumbled, you see, so we must, so there's a trick here, okay? There is a trick here which you must know, okay? You must not copy and paste exactly the numbers the way they are, guys, I beg you, all right? This is 0, where the lines are meeting, you see, this is 0, you see, where the numbers are meeting, okay? Where these lines are meeting. Now, guys, you must not copy and paste exactly these numbers the way they, don't copy them here, 490, 310. You must not copy them exactly here, okay? They want to see here if you know how to deal with these numbers in the y-axis. Guys, are we together concerning this part? I beg you, in the y-axis, you must not copy and paste these numbers. There's a trick here, okay? They want just to see here if you know how to make a scale. They want just to see if you know how to come up with a what? With a scale. There is a trick here, all right? There is a trick. I hope, guys, you have heard. You must not copy and paste exactly these numbers, because if you copy and paste exactly these numbers, you may end up coming up with what? A wrong what? Scale. Otherwise, you will lose what? Marks. That's what you have to understand. You will end up losing what? Marks. So now let me teach you how to come up with a scale. Let me teach you how to come up with a what? With a scale. 490, it is a big number. You see, so 490, it is a big number, right? Then now we have 82. You see, so you are going to go to the big number and also the small number. So this is the small number, you see. So we have the big number and also the small number. That's what you should do. So you go to the small number, okay? And also the big number, okay? So the first key thing, identify the big, where it ends and also where it starts. That's what you should do, okay? Now, what should you do? It's way too simple, guys. You do this. Where your scale should start, it is where you must pay extra attention to the small number. First, start with a small number, all right? First, start with a small number. The small number is on what? 82. Then the big number is on 490. What should you do? Go here, this 82, which you are seeing, this 82, okay? Try now to look for the number, okay, which is below, okay? So the number which is what? Below, okay? The lower number. So this is 82. So now here, since this it is in the 80s and they simply expect you to end in the hundreds. Take note, these are in the hundreds, but this it is just in the 80s, okay? So now here, what I can simply tell you is this. When you are coming up with this, these are the numbers always when it comes to the y-axis, okay? These are the numbers whereby they do expect you to do what? To use. You see, if it's not 5, then it's 10. You see, so if it's not using 5, then they're going to use 10. Then if it's not 10, then it will be what? 15. Okay, and most of the time including 20. So these, they are very much common. Okay, then now aside from this, also the common number here which you have to know, it's 50. Okay, so these are some of the common numbers when it comes to what? When it comes to the y-axis, and including here 2. Okay, let me say 1 and 2. What you have to understand, so 1, 1, 2, 3, 4, 5, you go up, or 2, 2, 4, 6, 8, 10, or including 5, 10, 15, be it 20, or up to 50. Okay, now check. We have 80s. Okay, so 80s, start by looking at 50. Okay, make sure that in the y-axis, it must be longer. In the y-axis, at least the numbers, they must be longer. All right, so these are some of the what? Of the common what? Numbers. So including the same 100 units. Okay, so these are some of the common ones: 1, 2, 5, 10, 15, 20, 50, 100. These are one of the common ones. All right, so now here, what should you do? You do this. Okay, you start doing this key thing. If you check, guys, here there is 1. Okay, and how many numbers do we have here? How many numbers do we have here, guys? How many numbers do we have? How many numbers? How many numbers? How many numbers do we have? When you talk about the smaller number, how many numbers do we have here? There are 2, right? So you start doing this. There are 2, okay? The first number, it's what? It's 1. So here, this one we cancel. This one we cancel. You cancel it like this, okay? Because we are looking for a number which is going to have what? 2 numbers. Also we go. Here we are having 2, okay? Okay, here it's 1 number. Also here 1 number, we are going to cancel. Okay, here we are looking for a number which has 2 numbers. All right, so also here it's 5. Okay, we cancel it because these are just single numbers. Okay, then now we move. Here it's 82. It's 82. There 1, 2. Also here we are having what? 1, 2. Let us try 10. Okay, and once you use 10, make sure that you must end where? On 400 or just 500. Take note. Here they are saying 490, which means we can even end up to 500. Okay, so can it fit? 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. No, it cannot fit. Even if we extend, it cannot even reach at 500. So we cancel this 10, we cancel it. Okay, 15 also it cannot reach. 20 it cannot reach. 50, let us try 50. Let us try 50. 0, then 50, okay, 100, 150, 200, 250, 300, 350, 400, 450. Okay, we can even go beyond 500. Okay, we can even extend it here. We can even extend it, guys. Let me even extend it a bit. 50 fits. Also 100 here it can fit, guys. 0, 100. Okay, by getting now that scale of using two boxes, whereby we can say here 100, so that here it's 50. Then also here 200, then also here 300, and also here 400, then 500, like this. Okay, that also other one can also fit, So here, guys, which was way too simple? Should we use for 50 of going 50, 100, 150, 200, or we should use that to other one of getting two boxes like this? 0, 100, then we go 200 like this. Between the two, which one can you manage for 50 or for 100? Which one can you manage? For using 50, 50 is better, right? Okay, so here you say 50, then you say 50 plus 50, it's what? 100. Then 100 plus 50, it's what? 150. Then 150 plus, it's 200. Then 200, it is 250. Then 250 plus 50, which is what? 300. Then 300 plus 50, which is what? 350. Then here, which is 400, like this. So we can even extend a bit, okay? Then here, which is 450, like this, okay? So we can even extend a bit here, all right? Let me even extend a bit, guys. Where is my other pen? Let me even try to extend a bit. Okay. Let me even try to extend a bit. Okay. 500, like this. Okay. Guys, you must not end off on 490, all right? So at least end on the next number, like 500 here, all right? So that is way too perfect. Okay, like this. This is the y what? This is the y-axis. Like this, you do as wise. You see, ka? So here, you see, ka? 50, 100, 150, like this. So these are some of the common numbers, guys, you see, ka? So these are some of the common numbers, you see, ka? So here, when you are looking for a smaller number here, the common numbers which you can end up finding 10, 15, 20, in the range of just, let me say, 20, 10 to 50, when you are looking for a scale of, let me say, two numbers. These are way too common, okay? Or let me just say 5 to 50. These are way too common, all right? When you have two numbers here. So a scale of 5, starting from 5 up to 50, because these are way too common. All right, so 5 to 50. So looking for a number whereby you can use here. Okay, I hope it's way too clear, guys. If you want, you can use the scale of 100 still, but make sure you'll be using two boxes. But this one is way too simple. At least you will be following box by box. Now let us start. Here, guys, then now when it comes to time, on time, we just copy and paste exactly. Okay, so you will just go directly. So we have 0, we have 15, we have 30, we have 45, we have 60. We have 15. So here, when it comes to time, we just what? We just copy and paste. We must not tamper with time. We just copy and paste. So 0, 15. So here, 30, 30. When it comes to 45, okay. So 45, 45. Then now we're having what? 60, like this, you see? Like this. So when it comes to time, make sure that you just copy and paste, okay, like this. 0, 15, they were adding 15 here, 15 plus 15, 30, 30 plus 15, 45, then 60. That's what they were doing, all right? You can just copy and paste exactly here like this, all right? Then now, here we can start now. Okay, okay, so I have seen a question here, guys. At what if you are given numbers with points, which means these, you see these 2 my points which you are seeing, these 2 my smaller boxes, you see, these 2 my smaller boxes. Are you seeing these 2 my smaller boxes, guys? These 2 my smaller boxes which we are seeing in between, they will be used, okay? They will be used. Guys, are we able to see these 2 my smaller boxes which are between 0 up to 15 or 0 up to 50? When they've asked you, when you see the numbers here in the box, they are having points. Have we seen these, guys? Okay. Have we seen these? So which means these 2 my boxes, they will be what? In use. Let us assume here, okay? Let us assume that they want what? They want, let me say, they want, so these are the points which they're talking about. These 2 my boxes, I will explain later. Let us finish first. Let us finish. Due to time, let us plot so that you see. So guys, you must not copy and paste when it comes to the y-axis, okay? You must not go ahead when it comes to collecting the numbers in the y-axis. There is a trick. Make sure that you look for the scale. So there are 2 numbers here. They're now starting from 5 between up to 50 there. There's a number which you'll be using now to do what? To detect the scale. Now let us start. What is the first coordinate, guys? 0, what? 490. 0, 490. So you are going to go where 0 is, guys. This is 0. Then 490, it's where? 490, 490, 490. Here it's 450. You see, so here it's 450. It's 450. That's what you have to understand. But in this case, they are looking for what? They want 490. That's what you have to understand. So guys, here it's 450. Now, how are we going to reach on 490? How are we going to reach on 490? So here we are going to do this. Guys, if you check, are we able to see these 2 my small boxes? You see, so these 2 my small boxes, since here is what? It's 450. If it was 400 here, if it was 400, would have said a smaller box, it means 10. All right, let us assume that here it was 400. You see, guys, let us assume that here it's 400. You see, if it was 400 like this, would have said this first box represents 10. Each box here represents what? 10, 10, 10, 10, 10 up to the end. If we had the 400 here, so we would have said 400, 410, 420, 430, 440, 450, okay? 450, 460, 470, 480, 490, okay? If we use the scale of 100, we would have said each single box here means 10. So that we reach on 490, then 500. Okay? Have you seen, guys? If we use the scale of 400, each box here would have been 10. Because it would have been 400, 410, 420, 430, 450, 460, like this, until we reach on what? 500. But now, guys, here we have what? 450. You see? Here we have what? 450. That's what we're having. You see, we have 450. So this simply means 2 boxes. We'll be getting the 2 boxes so that we reach at what? 500. Okay? If you just have a direct number here, a single box will just refer to one number. But take note, we have 450, 450. This simply means we will be getting two boxes to represent the 10. So here there will be this box and this box. We are going to say 460. You see, then this box and this box, they are going to represent 470. Okay. So here, this box and this box to represent 480, then 490. That's what you are going to do. So here, it's what? It's 450. So we will be getting two boxes. So two boxes to represent what? 10. So we will be getting what? Two boxes to do what? To represent 10. Okay? To represent 10 units. That's what you're going to get so that we reach on 500. So what are we going to say? So here I will be using this part, 450. So I will say this box and this box, 460, 470, 480, 490. So it's here. You see, this is where the point is. So this is 490. You see, because if I continue going like this box and this box, 500. Have we seen, guys? Have we seen? So you have to be very much careful a bit here. If you just have a straightforward number like 400 here, a single box would have been representing 10. Okay? But here, if you're having a number which is having a 50 like this, two boxes here will be representing what? 10. Is it clear here? Then we have 310. Let us go to where 310 is. Guys, we have 300. You see the way they are, 300. So we will be getting two boxes. You see, we will be getting two boxes. So 300, then we are going to say this box and this box. Okay, so this is where it is like this. You see, this is where the 310 is. Okay, because we'll be getting two boxes. Why? Because we have used this scale of getting 50. So 50, 50, 50, we'll be getting 2, 2. If we used a scale of 100, we'll be getting each box to be what? To be 10. That's what it means. Now, what are we going to do? Here they have said what? 310. 310, comma what? Comma 15. So take note, we will do this. We go where 15 is so that they meet. They meet, they meet, they meet, they meet, they meet, they meet here. So this is where they're going to meet. So here, the two boxes like this. You see, so this is where the point is. You see, this is where the point is. Then now also we go to the other numbers, 30, 190. We go where 30 is, like this. Okay, now we look for where 190 is. So here, this is 100. So here we say two boxes, which is 110, 120, 130, 140, 150. You see, this is 150. Now they want what? 190. So we will go 160, 170, 180, 190. So here, you see, this is the part. Okay, now they want what? 30. 30, this number. So here, that's where the part will be. The dotted line will be like this. You see, now here we move. We have 45, 118. 45, 118. Okay, here we have 100. Now they want 118. So two boxes. So 110. Okay, so which means here 110. Okay, 120. Now they want 118. What should we do here? So here you do this. This is 110. Okay, this is 100. Then two boxes, 110. Then now here, if we get two boxes, it's 120. Now they want 118. So you have to get three boxes. Now when they ask you to find the same 118, because if you go to the other part, it's giving you 120 flat. So if you are getting two boxes like this, you are getting these two boxes like this. Okay. Now, if you have observed that, okay, if you extend, it's giving you the other number like 120. You have to get three boxes. You say this and this, then you just get one box. You just end from here, okay, like this, because you don't want to extend. All right. So here we say 100. This is 110. You see, so this is 110. Then now we're going to get this box, the number 3 box here. This one It's more like just you get it or you cut in between it. Like this. Okay? You do as wise. Like this. Okay? Because here, there is no 118 here, all right? Because you just have to get 1, 2, then now you just get the box number 3, or you just cut it like this. So what should you do? Comma what? They want it with comma what, comma what, comma what, comma 45. So here we are going to go. We get 3 boxes, 1, 2, then 3. So here we are going just to do this, you see, or you can cut it in between. Okay, then now here we move. The last part, 60, 82. So this is 60. Now they want 82. So take note, we have 50. So 2 boxes, 60, 70, then 80. Now they want what? 82. So if we go ahead, it will be 90. So we have to get this. They got small box. So 60, 70, then 80, like this, okay? Now we go a little bit further, okay? Here in the other box, because they want what? They want 82, okay? So you are going to go into the single box. They want 82. So here we say 1, 2, okay? So which is 60, okay? So 2 boxes, 60, 70, 80, then here, okay? In between, just like this, in between this box, don't get the entire 2 because it's going to be what? To be 90. So here you come, you follow, you follow, you follow, you follow, you follow, you follow, you follow. This is 60. This is 60. Make sure that you follow, you follow, you follow, you follow. This is box number 4. If we go like this, okay. So 1, 2, 3, then 4 in between, like this. Here, like this. You see, ka? I hope 1 or 2 things have been gotten. I hope 1 or 2 things have been gotten. Then now, after doing this, what are you going to do? You have now to use your pencil to join the points. Make sure that you join the points very well. Join the points with using your hand, all right? So join. So here, join them just using your hand, all right? So join them, join them, join them, join them, join them using your hand like this. Just follow the points like this, okay? So this is what you call radioactivity. Join them using your hands. So join them, you join like this. You join them like this. Okay. You join them like this. Okay. If you want, you can even extend it down. Okay. It's up to you. You see, ka? This is how you get to do this graph. You see, ka? This is how you get to do this graph. And you will end up getting what? You will end up getting 4 marks. Okay, how is it? How is it, guys? How is it? How is it? All right. So you have to be very much careful enough when they ask you to plot a number, whereby if you see, if you are going 2 by 2, or rather 1, it's not giving you that number. Make sure that you cut in between. Okay? This is how we should do. Yes, clean, you see, ka? Yes. Now, this is how you get to present your work. Then question number 2. Question number 2, you do this. You see, ka? Everything must be answered on the graph, guys. Everything must be answered on the graph paper. You do this. So the other question, you even do this. You see, ka? You do this to show that, okay, this question you are done, you are going to the other question. So indicating question numbers, it is very much important. So this is question number 1, okay? So this is question number one. Okay, this was question number one, Roman numeral number one. So number two, you should even be indicating. So the other question was saying define half-life. It was saying define half-life. Okay. So here, what you should understand when you talk about half, okay. So here, half, we all know that half is like this. We write half like this, 1 over 2. All right. So what you have to understand when you talk about half-life, half-life in short, we are simply talking about what? The time it takes. All right. The time it takes for a sample to decay by what? By half. Now, guys, what you have to understand is that half-life, we are simply talking about time. Half-life is measured in minutes. Half-life is measured in hours. Half-life is measured in seconds, is measured in days, is measured in weeks, is measured in years. When you talk about half-life, we are simply talking about time. All right. Take note that half-life is measured in a bit days, years, months, minutes. Okay, that's what half-life is. Okay, so now here, that's what we have to know and also understand. Now let us define what the same half-life is. Take note, this is the time it takes, all right? So we say half-life. What is half-life? We say half-life is the time taken, you see, is the time taken, okay, for the for the mass for the mass of the the sample, for the mass of the sample to decay by half. To decay by what? To decay by half. Okay, so half-life is the time taken for the mass of the sample or for the mass of the radioactive sample to decay by what? By half. This is how you can define it in a very simple way. Is the time taken for the mass of the sample to decay by what? By half. Or others, they can simply define it in other ways, saying that it is the time it takes for the radioactive, let me say, sample to decay by what? By half of its element. Okay. Yes. All right. This is how we get to do it. Now, guys, what you have to understand also when you talk about the same half-life, okay, here, you see, let us assume that here I have 200. Okay, here I have 0. Here I have 10, 20, 30, then 40. Okay, so this is the mass of the sample, and this is the time. So if they ask you, this is the graph, right? Calculate the half-life. So the half-life, take note. So the half-life here, take note, equals to what? To half. Half times what? This 200 which we are seeing here, it is the original mass. So this 200 which we are seeing here, it is the what? Original mass, because that's where the graph normally what? Normally ends. Is the original what? Mass. When plotting, that's where it starts from. This is what you call the original mass. Okay, so when they say calculate the half-life, you say 1 over 2 times what? The original mass. You say 200. You say here, what are we going to do? We know that 1 times 200, it's what? It's 200. Then divide by what? 2, which is what? 100. Guys, that's not the half-life. When they say half-life, what are they looking for? They are looking for what? That your answer must be in what? In time. Be it in years, be it in minutes, be it in seconds. So after dividing this 100 which you have seen here, you have to look for it here. Okay, let us assume here we have 100, then we have a 50 here. You see, so when you divide, when you say 100 divide by the same 2, this is 100. So this is the curve. This is the curve of half-life which we have plotted. We have already plotted it. Okay, so now here 1/2 times where? The original mass. After dividing, you find the answer. Look for where this 100 after dividing it is. So this is where 100 is. Then you start doing this. You see, you start doing this, creating two dots so that they touch the what? The curve. Then come down. Okay, where it lands, okay, it's on what? 10. 10 what? 10 years. So half-life is what? Is 10 years. This is how you get to calculate half-life. You see, so the first key thing, you write 1/2 times what? Where the graph normally starts when it comes to plotting. Then after doing your calculation here, the answer which you have found, you should look for it on the y-axis. After looking for it, start creating two dots using your what? Your pen. Where it from up upon just reaching where these two dots touches the what? The curve. Now come down like this. Where you reach, that's the what? That's the half-life. Have we gotten something here, guys? Have we gotten something how to calculate half-life? The time it takes for the mass of the radioactive sample to decay by half. So it's way too simple to calculate half-life. Half, guys, it means 1/2. So 1/2 times what? Times where the graph ends here. Then upon dividing the answer, start looking for it here. Start creating two dots where you land here. That's the half-life. Take note, it is measured in years, in minutes, in seconds. That's what you should do. All right, now you see my graph, guys, how it looked. So the time it takes for the mass of the sample or radioactive sample to decay by half, that's what radioactivity, or that's what half-life is. Okay. So this is how we get to plot the graphs whenever it comes to physics. Okay. So this is what you have to know and also understand. And guys, sometimes the graph can come already plotted. Sometimes the graph can come already what? Plotted. Okay. Sometimes they can even plot the graph for you. Then now you start what? You start solving directly. You start solving directly. Okay. You just start solving directly without wasting what? Without wasting time. I think I do have a question here whereby the graph was given already. Then now you just have to go ahead in terms of plotting without wasting time. I think it was here, if I'm not mistaken. A minute. Let me just look for that question whereby the graph was already plotted. I think it is here. Yes. Yeah, somewhere here. That's where the question is. Yes, the question. All right, it's here, guys. Have we seen, guys? Is it visible? Is it visible, guys? It's visible, right? Now let us answer. Let us answer, guys. Let us answer. So that we look at other graph questions. So that we look at other graph questions. Possibly the ones which have points so that I explain also. Okay, perfect, guys. So the question here says, a detector of nuclear radiation was set to measure the decay of a radioactive substance. Figure 12.1 below shows the results of the experiment. Check, guys. We have the count rate per second, 0 ending up to 2000, then 0 ending up to 5, which was in hours. Guys, what is the half-life of the substance? Uh-huh. What is the half-life of the substance? So now here, I want you to solve, guys, and tell me the answer. Get a piece of paper, guys. Get a piece of paper and solve for me. Mhm. What is the half-life of the substance? Okay, get a pen, get a pen, get a pen and do it. Don't forget, guys, half-life is equals to what? 1 over 2 times where the graph starts from. They now come down. Okay? Okay, guys, they are also, okay, Cornelia saying 1.5 hours, sir. Shadrick saying 1.5. 1.5 what? Shadrick. For one, it's 1.5 bright. All right. Perfect, guys. Perfect, guys. All right. So here, like what we said, that what? That half-life is equals to what? 1 over 2 times what? Where the graph starts is where? On 2000. That's what you do. Times what? Times 2000. Like this. Okay? Then what are you going to do? You say here, 1 times 2000, you say, which is like this. Okay? Here, what you should do, okay, is as follows. Now, here we end up doing what? Divide by what? 2. We all know that 2 into 2 is what? It's 1. 1000 like this. Okay, now we go where 1000 is. So if we go where 1000 is like this, it will be here, which is what? 1.5. All right, so it's 0, 0 0.5, then 1, 1, 1.5, 2, 2, 2.5, then 3. Okay, so here it's what? It's 1.5. So it's 1, 1.5, then what? 2. So the correct answer is 1.5 what? Hours. Correct? Now, guys, clearly explain how you obtained your answer to A, to A Roman numeral number 1 above. Yes, guys, let us explain how we managed to get this answer. Now they want English here. You see, say, I started first by finding the half-life of the sample, then after finding the half-life of the sample, what? Dividing, what? So a proper sentence here must be constructed because you are simply explaining how you got to find the answer, okay? How you managed to find the what? The answer. Waiting for you guys. How have you managed to find the answer? Explain how you have managed to find the answer. Clearly explain how you have managed to obtain your answer. How have you managed to find your answer, guys? Anyone to clearly explain? How would you explain the way how you have managed to find the answer? Okay, so Cornelia is saying it's because the half-life of 2000 is 100, then what? Yes, because the half-life of 2000 is 1000. Then now you end up saying now, upon looking for it on the y-axis, then drawing or by coming up with dotted lines touching the curve, then that's when 1.5 was found to be what? To be the half-life. It's more like just you are explaining it in your own what? Way. how you have managed to find it. End up saying the half-life of 2000 is 1000. Then upon doing some calculation on the graph, the half-life was found to be what? To be 1.5. Okay, so upon doing some calculation, the half-life was what? 2000. So now here, that's what it was. Let us move, guys. B, list any three properties of a beta particle. Take note, you're explaining using your own words here, right? How you have managed to find. List any three properties of a beta particle. What are the three properties of a beta particle? What are the three properties of a beta particle? That's what we were doing. Mhm. What are the three properties of beta particles? All right, so Vupe said we first started by calculating the sample, and from there we use 2000 on the curve, then we dotted the lines to reach. Yes, you explain it like that, right? Using your own language. So Cleopatra saying, okay, it's a fast moving electron, there's a negative charge, can be stopped by aluminium, all right? Then others, three properties. Orims is like the definition got into your mind, eh? Okay, correct. And it is has guys, the English, I beg you. You do have good answers, but the English, just let us try to work on the English, guys. Okay, okay. Let us try to work on the English, guys, the way we construct the sentences, because that may end up costing us a bit. Okay. Yes, your answers are way too correct. Let us just try by all means. Okay. Now you have remained with one, Christabel. Noted down. Okay. The answers are correct, guys. Mhm. Keep on going. I want two more. Okay. Interesting. Okay. Okay, I'm seeing the answers. All right. Interesting. I have seen enough now. Okay. Okay. So now here, perfect, guys. Interesting. Describe how you would show. Okay. Interesting. Okay, perfect, guys. The number three, and then let us see. Describe how you would show that the radioactive source is emitting only beta particles. Mhm. Describe how you would show that the radioactive source is emitting only beta particles. Mhm, mhm, mhm. Describe how you would show that the radioactive source is emitting only beta particles. Mhm. Like what we said, guys, saying that the beta particles are only what? Are stopped by what? By aluminium. So that's what they are looking for here. All right. You can end up saying it can be shown because the beta particles are what? Let me say, can be stopped by a thin sheet of what? Aluminium. Okay, they can be stopped by what? Aluminium, because they're saying describe how you would show that the radioactive source is emitting, okay, is releasing or producing only beta particles, because the beta particles, they do what? They are stopped by what? By aluminium, okay, which can only be which can only be on beta particles. Take note, the alpha particles, it's paper. The beta particles, it's aluminium. Then the gamma rays, it's what? Lead. All right. So here, that's what we can simply talk about. Now, yes, you're still commenting the answers. All right. So now here, we move to the other part of the graph. Which is like this. Here, here are the other graph questions. Okay. Right, a minute. Let me just look for the graph questions. All right. Now I don't know how it will be placed now. I don't know this one. Are we still available, guys? Okay. All right. So here we also have this other graph question under radioactivity. We also have this other graph question under radioactivity, this one. All right. Just a bit. We are not done with radioactivity because we are not yet done a bit. Okay. We are not yet done a bit. So we also have this graph question. Okay. Guys, don't forget what I've said, all right? So this table, put it at the corner of your graph paper, then write the title, which is what? Count rate against time. Okay, then you start now what? Doing the same thing. All right, then you start what? Doing the same thing what we are doing. Okay, the questions are just one and the same. Okay, the questions are just one and the same, one and the same. All right, so let us go a bit now into a bit of a lesson so that we also look at the other key thing which we have to know. Now, guys, after this now, okay, now let us start. So here we have talked about the introduction part, radioactivity, and also not forgetting the same part of what? Of half-life. All right. So a bit before we go into half-life, you have also to know what background what? You have also to know what background radiation is. You have also to know what background what? Radiation is. Okay, they can also ask you to define what background radiation is. Okay, so background radiation is a natural radiation, okay, which occurs on the environment, okay, which occurs in the environment. Okay, that's what you have to know, that background radiation is simply a natural radiation which which occurs in the what? In the environment. Actually, this is just a natural environment which occurs where? In the environment. Then now here under the same key part, they can also ask you to do what? To state the sources, okay? To state the sources. So the first name, it is the y-axis. Then the second part, it is the y-axis, okay? Like they say, plot the graph of voltage, plot the graph of voltage against time. You see, ka? Voltage, it is the y-axis. Then this one is the x-axis. So what is starting, it is y. What is ending is x. That's what it means. I hope I've answered you. Okay. Hope I've answered you. Okay, I hope I've answered you. So they can also ask you, take note, background radiation is a natural radiation which occurs in the environment. Now, what are some of the sources? So we do have rocks, in short, which are just stones. Okay, so we do have rocks, or you can simply say stones. All right, stones. Okay, we also have what you call cosmic rays, actually from the space. Okay, then aside from this, also we do have radon gas. Okay, to mention a few, they can simply ask you to give one source, state one source of background radiation. Okay, here we have rocks, we have cosmic rays, we have radon what? Gas. So these are some of the what? Of the sources of the same background what? Radiation. So here, that's what you have to know and also understand. Okay. So radioactivity, so the sources of radioactivity are divided into two types. We have the natural sources and also the man-made sources, all right? So the natural sources are the ones which we have here. So the rocks are natural, they are found on the environment, okay? The cosmic rays from the space, okay? Then the radon, let me say gas, it is found on the ground. So these are some of the natural sources. Take note, like radioactivity, the sources of radioactivity, the source of radioactivity are in two types. We have the natural sources and the man-made sources. Okay, we have also the man-made what? Sources. All right, so that's what you should know. Okay, that's what you should know. Okay, then now the man-made, we have now the man-made. So one of the examples of the man-made, these are radioactive isotopes which are used in medicine. Okay, these are the man-made now. Let me say best example, I can simply say radioactive isotopes, radioactive isotopes used in what? Used in medicine. That's what you have to know. So what is background radiation? Is a natural radiation which occurs in the environment. What are the sources? or rocks, cosmic rays, radon, gas, then the man-made one, okay? These are just radioactive isotopes which are used in what? In medicine. But pay extra attention to this part, the definition and also the sources, okay, the natural sources. Now, aside from this, it is also very much essential that you do as wise. You also have a strong backup when it comes, when it also comes to this part, okay, um, safety ways, safety ways of handling what? What are some of the safety what? Ways of handling what? Radio, radioactive what? Radioactive samples, okay? How safe can you handle these radioactive what? Samples, okay? By wearing gloves, okay, goggles, putting on goggles, okay? Now, guys, this question goes to you. What are some of the safety ways of handling radioactive samples? Mhm. In order for you to handle radioactive samples, what should you do? Mhm. Uh-huh. Mhm. What are some of the safety ways? Mhm. Yes, you should wear protective what? Clothing. Wear protective what? Clothing. So you should wear protective what? Clothing. Then aside from that, in such a way that by putting such as what? Let me say such as gloves like this, and also a lab coat, okay, like that, right? So by putting on a protective work suit and radio, so glasses, okay, putting on glasses, all right, yes. So these are some of the key things that you just have to know here, the safety ways of handling these key things by wearing protective clothing like gloves, okay. So these, they do play a very important role, okay. Make sure to do as wise, yes. All right, just knowing here something is way too perfect. All right, then now at least you must also have a proper backup when it comes to knowing the definition of this nuclear nuclear fission and also nuclear fusion like this. So nuclear fission and nuclear fusion like this. You see, nuclear fission and nuclear fusion. The word fission simply means to split, and the word fusion simply means to join. That's what you have to understand. So fission simply means to split, then fusion simply means to join. Mhm. That's what you have to understand concerning this part. That's what you have to know and also understand concerning this what part. Now let us try to come up with a definition. Let me drink some water. I'm coming a bit. All right, perfect. Then now, what is nuclear fission? Take note, fission simply means to split. So nuclear fission is the splitting. Actually, we are splitting the large, let me say, nucleus. So nuclear fission is the splitting of a large what? Of a large nucleus, of a large nucleus into or more into or more smaller nuclei like this. Fission simply means to split. So nuclear fission is the splitting of a large nucleus into or more smaller nuclei. All right. Actually, they normally release many in terms of what releasing a large amount of energy also. So take note, this one involves splitting. Then the other one, nuclear what? Nuclear fusion. This is the now the what? Is the joining. So this one is the joining of what? Is the joining of two, the joining of two small, is the joining of two small, let me say nuclei to form a large nucleus. To form a large what? Nucleus. Take note, this one we are splitting in order to release what? Two, okay? So, sir, I will get it wrong if I answer like that. Okay, sir, will I get it wrong if I answer it like that? No, it's way too perfect. Like the other one, okay? Like the other one which you gave, okay, is the splitting of the radioactive nuclei. No, kind, because we fission, okay? We normally split the large nucleus, okay? You cannot just say the splitting. We split the large nucleus. It's more like this is the nucleus, okay? Then now we split it like this, okay? So once we split it, we are going to release two things. So two things will be produced, okay? We have A and also what? B. So these are the smaller what? Nucleus, okay? So it's the splitting of a large. We are splitting this large nucleus into or more simpler what? Smaller nucleus. Then now fusion. These, the smaller ones, once they come together, they are going to form what? A fusion. I hope something has been grasped. We have H big nucleus. If I split it, it's what? Fission. If these two things which I've splitted, if they come together, they form a large nucleus. That's what you call fusion. I hope something has been grasped. Okay, that's what we are simply talking about. Yes, perfect. Since we can only split something which is big, all right, you cannot split something which is kind of small. That's what you have to know. All right, guys. Then now, what should we do? At least now we go, at least you just have to know these key stuffs for you to be kind of safe. Uses. What are some of the uses of alpha particle, beta, and also gamma? Okay. So these ones, the alpha particle number one, these are simply used to detect smoke. They are used to detect smoke in industries. These are simply used to detect what? Smoke. Detect smoke in what? In factories or industries. So these are simply used to detect smoke in industries. Then the beta particles are used to treat bone cancer, treating bone cancer. So the beta particles are used to treat bone cancer. Okay. Then these ones are also used to treat cancer. Okay, be it the skin one. Okay. The gamma particles, they can cause cancer. They can also treat cancer. Okay. So the alpha particles are used to detect smoke in industries. The beta particles, they are also used to treat bone cancer. The gamma rays, they are also used to do what? To treat cancer. Then the other use, which we can simply talk about, I hope we are together. People may end up sleeping now. Okay. Are we together or people are dozing? Perfect. Okay, perfect. Also, these ones, the alpha particles, they are also used to treat some types of cancer. So they are also used to treat some types. So these also the alpha particles, they are used to treat some types. Actually, not all the types, but some types of what? Of cancer. So the alpha particles, they are also used to treat some types of what? Of cancer. Okay. Some types of cancer. That's what you have to know. Also, these they are also used to treat eye diseases, treating treating eye diseases. They are used also to treat some eye diseases. These ones, okay. Also, these ones they are used to kill bacteria in food. So also these ones, the gamma rays, they are used to killing bacteria in food. They are also used to kill bacteria in food. And also in sterilizing medical equipment. Okay, so I think these they are enough. Here too, here too. So these ones to detect smoke in industries, they are used to treat bone cancer. Here just cancer or be it skin cancer. Okay. Yes, it can also be used to prolong the life of tomatoes, the gamma rays. Yes, many uses are there. There's many uses, guys. Many uses. All right. That's what you have to know. All right. So I hope one or two things have been gotten on radioactivity. I hope one or two things have been gotten on radioactivity. To all those who joined in the afternoon, they have benefited a lot because they know the intro part of this. So if you haven't watched that part, I beg you, try by all means to just know the intro part. Okay. All right. So now here. All right. So as for now, here guys, what you have to know is this. Here, when we talk about section C, guys, okay, yes, they can also cause cancer, they can also treat cancer. Yes, it can cause cancer and also it can treat cancer. That's what gamma rays are. They can treat and also they can cause cancer. Okay, one harmful effect of them, they can cause cancer. Okay, one use, they can also treat cancer. Also to prolong the life of what? Tomatoes. Also to sterilize, okay, health equipments like that. So section C, guys, this part carries 20 marks. When you talk about gamma rays, yes, they can cause skin cancer, they can cause cancer, but not the use. It's not the use, okay? Okay, that's what you can do. So when you talk about section C, that's what you have to know. We have 20 marks. So section C, guys, carries 20 marks. So what you have to know is this one. Number one, here, we do have some graph questions here and also the questions which do not carry some graphs. That's what you have to understand. We do have some questions whereby they are asked in form of graphs and also not in what? In graph questions. That's what you have to know and also understand when it comes to this part. All right, so the questions are asked in form of graphs and the other ones are not asked in form of what? Graphs. That's what you have to know and also understand. Now, let us move here. Number one, in section C, you can meet the same radioactivity when it comes to plotting. So radioactivity, mainly when it comes to the graph part, asking you to plot it. And if not radioactivity, you can meet current, electricity. So these are the graph questions, okay? Whereby you can meet here, whereby they're going to ask you to sketch voltage against what? Against current, like this. So these are the graph ones. So radioactivity graph, current, electricity graph. The number three, you can also meet the likes of the time graph. Okay, so these are some of the key things that one has to know and also understand. Also, we do have the likes of what? Hooke's. We have also what we call Hooke's what? Hooke's law. That's what you have to know. We have Hooke's law, we have time graph, we have current, electricity, we have radioactivity. So these are some of the key things that you have to know in order for you to be kinda safe in section C. All right. So here, guys, how many know something on radioactivity graphing? From what I've taught, I think one or two things have been gotten. Can you manage to sketch a graph? Can you manage to sketch a graph? Can you manage to sketch a graph under radioactivity? Can you? All right, perfect. All right. Then what of current, electricity? Take note, the format of finding these graphs is just one and the same. Okay, the format of plotting these graphs is simply one and the same. All right, there's nothing different. You draw the box at the corner, the title, then you start. That's how you get to write them. All right? So these are some of the key things you should also what? Know and also understand. Okay, so here I have shown you how to do this one. Okay, the rules which are used also here, they are used like this. So we are going to go to this part, current, electricity. We are going to go to current what? Electricity. My aim is for you, at least you must be familiar. Okay, I want you to be familiar. That's what I want. You must be familiar when it comes to solving these what? Questions. You must be familiar. Okay, because these questions, whether you like it or not, you are going to meet them there. Okay, you are going to miss them there. Take note, this is the half-life which we did. The half-life which we did. You see, then now here, then now guys, I have also the new graph. Let us do this one, voltage against current. Then also if time allows, we can even do some Hooke's law. Take note, the rules are just one and the same here. The rules are just one and the same. One and the same. So let us go. Let me try to look for the question under the same thing, voltage against current from the papers here, which I do have. So here, okay, they are available here. Okay, I have found it. I have found it here. I have found it. So my main aim is for you to know how to plot. That's what I want. I just want you to know how to plot. The other key things, they will be looked at later, but section C, guys, is 20 marks. Guys, is 20 marks a small thing? Mhm. Guys, is 20 marks a small thing? Is 20 marks a small number? Is 20 marks a small number? Yes, for the time graph is just one and the same as that in mathematics. But in here, you just have to do what? You just have to state some of the key things that are involved, such as each, let me say by mentioning the acceleration part, retardation part. Here the car was retardating, was moving at a constant speed. Okay. Here in physics, we normally indicate, okay, each and every what distance which the car took from here up to there. Okay. Yes, you see, you cannot. Now, guys, this is how it gets to come. Okay. So this question A, I will talk about it later when we are done plotting because we are looking at time. Okay. You must rest also. Okay. So I will explain this part later. Let us go direct to plotting. Okay, because that's where marks are. B, A, and before I even start, how many are facing challenges when it comes to chemistry? How many are facing challenges when it comes to chemistry? How many are facing challenges in chemistry? I'm the first one here. All right. Okay. All right, guys. All right. I have seen. All right. I've seen. And as for tomorrow, we will be meeting once again, okay? So tomorrow we will be meeting. I will be helping you with chemistry. We are going to do questions on organic chemistry, question on more concept, questions on metals and also non-metals. Okay? I hope. No, chemistry is simple than physics. That's what you have to know. Because in physics, there are a lot of formulas. That's what you have to know. But in chemistry, you just have to understand the concept. Okay? Okay. Do you know that chemistry is so simple? Physics is hard. You don't know. Physics, chemistry is so simple. So, guys, okay, let us start. This is the graph paper. What is the first key thing that you should do on the graph? Upon now, if you want to do the question under graphs, what is the first key thing that you should do? What have I said? What should you do? The first key thing whenever you are handling a graph paper? What is the first key thing? Okay, someone is saying add a title. Okay, okay. What other key thing? Okay, someone is saying that correct, you should write it correct. All right, perfect. What you are saying is way too true, guys. So let us write, okay, yes. Let us write, or if you want, you can start with the title, then write the box. Or you can do it the opposite way. It's still one and the same. So here, let us come up with the box. Yes. Okay, let us come up with the box. So the box here, like this. Take note with a pencil, guys, all right? Do it with a pencil tomorrow, right? Not with a pen. Like this, all right. I don't know, some people, they are so surprised seeing me teaching physics. They are used seeing me teaching English. How many are so surprised? How many are so surprised seeing me teaching science? Many people, they know me very well. I'm well known when it comes to teaching English language. How many are surprised? How many are so shocked? Hmm? Okay, make sure that it's neat. Okay. Then now here we end up writing the same key thing. Make sure that you write it neatly. All right, it must be neat, guys. All right, so here. Oh, so you thought that I don't teach science? Eh? That's what you thought. That's what you are saying, Christabel. What about others? Aren't you surprised seeing me teaching this? So voltage, and also we have current. Okay, current. The box, you see the box. Then now here you end up writing the numbers now. So the boxes are 1, 2, 3, 4, 5, 6, 7. So there's 7 here like this. 1, right? So here 2, then here 3, then here 4, then here end up saying 5, right? So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, then 6, 7, done. Then the numbers, the first we have 0, 0. Then here we're having 2 on top, then 0.5 down. Then we are also having what? 4. Then we have 1.0 like this. Then we are having 6, 1.5. 6, what? 1.5 like this. We are also having 2.0. 2.0, then lastly 2.5. Then here 8, 10, 12. Sorry. 8, 10, then 12. Then here we are having 3.0. All right. Then now, that's the title. Voltage against, so voltage against time. Is it clear here, guys? Is it clear here? On this part, it's clear. Is it clear? We can manage to do these key things, okay? You can start with the title, then now you start with the box or the box, then now the title like this. Then now, guys, don't forget, this is the Y, okay? Okay, sorry, it's current. Thank you. You have seen, huh? Yes, it's current, not time. So it's current like this. It's current. Thank you. Voltage against current. So then what are we going to do? We let this first box breathe. All right. So that's what we're going to do. So here we draw a line to show the what? The y-axis. This is what you're going to do. So here, that's what you're going to do. Take note that even the last box must also breathe as well. We do as wise. So here we have the y axis. Then here where the lines are meeting, we have 0. Then here, this is what we are having. All right, so this is what we are having. Then now here, take note, guys. We have 0, 2, 4, 6, 8, 10, then 12. That's what we're having. We have 0, 2, 4, 6, 8, 10, then 12. All right, then here down, we just copy and paste here. Take note on time, we can just copy and paste exactly. So 0, what? 0, here we have 0 0.5, then 1.0, then we have 1.5, then lastly 3.0. Okay, then you see. Then now, here we are having 0, 2, 4, 6 up to what? 12. We can just get it exactly the way it is. Or we can even get for the one for 1, let us see, 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it won't be enough. Are people still available here? Are people still available? Are they still available? Are people still available here? Are people still available? So concerning this part of the box, we were smart enough. They were so lenient with us. So 2, 4, 6, 8, 10 up to 12, they were so caring. They were so caring. They were just direct, starting from 2. So it was 2, 4, 6, 8. Okay, it was 8, 10, then what? Then 12. Even if for 1, 2, 3, 4, 5, it can reach. Okay. Now here we have 2, 4, 6 up to going somewhere. Now here we can start now plotting. Here the first part, they are saying what? 0, 0. This is 0, 0, guys. Then now here they are saying 2, 0, 0.5. So this is 2, 0, 0.5 like this. So this, it will just go straight, whereby it has obeyed Ohm's law. 4, 1.0, we just do like this. It will just go straight. We get a ruler, then we join the points. That's all. 6, 1.5, 1.5, 6. Here, that's what you do. 8, 2.0, 2.0, what? 8. Then 2.5, 2.5, 10. This one is just way too straightforward. There's nothing to stress about. It's one of the simplest ever. Then also at the end, this chap. Then you are done. This one is just way too straightforward, guys. Then you just get a what? Just get a ruler and join the points. Then you are done. Okay, 4 marks for free. You see, okay? This is the voltage against current. This one is just way too straightforward. It will just come out straight. Okay. So here, you join the points. You join them. Make sure that your ruler is what? Is straight. Like this. Okay. You see? You see this one? It's just way too straightforward. Then now there are some questions down there. Okay, there's some questions which are down. Yes, you can write the scale. It's up to you. You can write the what? You can write the scale. Okay, you can end up even writing the scale concerning this one. Okay, concerning this one. You see? Okay, how is it? Does it look so hard? Does it look so hard? Then now here, there's some questions whereby they can ask you. They can ask you saying, has the graph obeyed Ohm's law? That's the question they can ask you. Has the graph obeyed Ohm's law? Take note, guys. If the graph is straight, if the graph is straight like this, it has obeyed Ohm's law. Okay? It has obeyed what? Ohm's law. Take note, Ohms was a scientist. The name Ohms, it comes from the name of the scientist who discovered about the same current, who discovered the same what? Key topic. Okay? So that's the first key question that you must ask yourself. So now here, this is question number 1. Then now here, let us assume that they have said, has the graph obeyed Ohm's law? We are going to say yes. Okay? Has the graph obeyed Ohm's law? Yes. Okay? Yes. Give a reason for your answer. We can simply say because the graph is straight, or it is moving in a straight line. Okay? It has obeyed Ohm's law because the graph is what? Is straight. That's what you have to know and also understand. Okay? So now here, that's what you have to know. Then the other key thing, they can also ask you to say, state Ohm's law. What does Ohm's law state? Ohm's law. Okay? So Ohm's law, that's what you have to know. You say Ohm's law states that. So Ohm's law states that it says that the current, okay, flowing, that's what it states. It states that the current flowing through a conductor is what? Is directly what? Proportional. Is directly proportional to the potential difference, which means the voltage, to the potential difference across it, provided, yes, we write on the graph paper, provided the temperature remains the same or remains constant. That's how you can state Ohm's law, saying that it states that the current flowing in, so the current flowing actually through a conductor is directly proportional to the potential difference across it, provided the temperature remains the same. That's what it states. That's what it gets to do what? To state. That's what it gets to state. All right, so now here, at least one or two things have been grasped. So if the graph moves straight, it has obeyed Ohm's law. Okay, this is what it means. Give a reason for your answer, because the graph, it is what? Straight. Okay, or the graph is moving in a straight line. Okay, so also stating what Ohm's law is, stating that the current flowing in a conductor is directly proportional to the potential difference across it, provided the temperature remains the same or constant. That's what a person must what? Know and also understand. So here, at least one can able to do one or two things. My main aim, I don't want you to enter blank. That's what I don't want. Okay. I don't want you to enter what? Blank. That's what I don't want. Okay, I hope one or two things have been gotten here, guys. What if it bends? If it bends, it has not obeyed Ohm's law. If it bends, or if one point here has missed, or 2 points they have missed, okay, it does not obey Ohm's law. If it goes like this, it does not obey Ohm's law. Okay, my main aim, I want you at least out of 20 marks, get a 16, get a 15 at least, okay? So that in section A, you fight a bit, okay? You fight. That's what I want, all right? You must not leave these free marks for free. These are free marks. Okay, so that's what you have to know. And also what? And understand, all right? You must not enter blank. That's what you have to know. So now, guys, too bad I am running out of my graph here. I have run out of my graphs here. My graphs are finished now. Are done. My graphs are finished as for now. My graphs are finished. So now here, also concerning the part of the time graph, no, Hooke's law is different. It's different, but the language is the same. Also there it obeys Hooke's law, but here it's kind of different because here it obeys Ohm's law, so I cannot say they are the same. There it obeys Hooke's law, but here it obeys Ohm's law. Okay. So here, they are going just, when it comes to the time graph, it is very much essential. You know these key things and also how to calculate. So here at AB, so the distance from here 0 up to B, here the car was what? This part is called acceleration, or the car was what? Accelerating. Okay. Then BC, the car was moving at a what? At a constant speed. If you check, it was straight here. It was straight. The car was moving at a constant what? Speed. That's what you have to know. Then here, CD, the car is more like was retaining, was retardating, all right? So it's called retardation. So this is very much essential for you to know and also understand. We all know that when we've been asked to find the total distance, so finding the total distance of this key thing, we all know that total distance, they want the total distance of the entire journey, which means the entire distance of the what? Of the whole graph, okay? Which means from 0 up to 10. So it's 1 over 2, which is what? A plus B, then H. That's the total what? Distance. So here at AB, the car was accelerating, then B was moving at a constant speed, no wonder it's straight. Then CD, the car was retardating or decelerating, all right? That's what it means. They can also ask you to find the total distance. So how are you going to find the total distance? So check, it's from 0 up to 10. Now, if you check on the graph, we do have what? These two lines, which we are seeing, you see, we are having these two lines, okay? We are having these two lines. You see two lines the way they are. Okay? So these two lines the way they are like this. Sorry. The other one is touching on 2, the other one is touching on 4. So what are you going to do? You have to subtract these two lines. So 4 minus 2, that will be your A. So in short, it's more like we're saying A, then here it's B. Where it's ending, it's B. So here you subtract this. So 4 minus 2, okay? Then now you end up solving, saying what? It's 1 over 2 open bracket. So here in between, 4 minus 2, it's what? It's 2, then plus where it ends, it's what? It's B. Like this, then H, where the graph ends, which is the height. 10, you put the 10 here. That's what you do, okay? Then now you solve. 2 into 2, 1. 2 into 10, that's 5. Then you end up saying 5 times 2, which is 10, plus 5 times 10, which is what? 50. What is the answer? 60. 60 what? Meters. That's all. Okay, so that's the total distance from here up to here. It moved 60 what? Meters. Okay, I hope something has been gotten here. Okay, I hope something has been grasped. It's more like the other one, okay? It's more like at what happened to the 2. Okay, I said 2 into 2, that's 2 into 2, 1, 2 into 5, 2 into 10, that's 5. You see, 2 into 2, 1, 2 into 10, that's 5. Then 5 times 2, that's 10. 5 times 10, that's 50. 10 plus 50, that's what? 60 meters. Have you seen? Have you seen? Or you want to go step by step like this? You see, 1 times everything here, it will still come back as everything. 2 plus 10, you see, it will be like 1 times 2, that's the same 2. 1 times 10, that's 10, then over what? Over 2. Like this, you see the way it is. Then here we're having what? We're having 10. That's what you're having. You see, here 1 times everything here, that's this. Then we are having 10. So here 2 into 2, 1, 2 into 10, that's 5. So 5 times 2, which is what? 10, plus 5 times 10, which is 50. Then what is the answer? 60 meters. That's all. Take note, distance is measured in meters. That's what you have to know. They can also ask you to plot this one, whereby your graph will end up looking like this. Okay, like a box, whereby when you be plotting, your graph will be ending like this. Here, you see a point. Here, a point. Your graph will be just like this. Will be ending like this. You see, this is how your graph will end up to be. This is how your graph will end up to be. You see, your graph will end up looking like this. Then they start asking you to find the what? The total distance to show the movement of the car at A, B, or this and this. Okay, this is what they are going just to ask you concerning the part of the time graph. Okay, which is very much essential and beneficial, what that one has to know and also understand. Okay, at least these are some of the backup that you have to know before entering. These are some of the backup ideas that one has to know before entering. Then now we move. Now the ending part. So before entering, that's what you have to know and also understand. All right. I hope I am helpful. I hope I have helped one or two, at least to have an idea when it comes to graphs. I hope I've helped one or two when it comes to graphs. Don't fear them, they are way too simple, right? Don't fear my graphs, they are just way too straightforward. You must not even fear them, all right? So do as wise and go and write, okay? So they are just way too straightforward. That's what you have to know. Okay, they are just way too straightforward. Now, the last part, we will talk about Hooke's law. Hooke's law. That's what you have to know. We are going to talk about Hooke's law. Now, guys, when you talk about Hooke's law, we are not talking about something which is going to strange. Okay. When you talk about Hooke's law, we are not talking about what? Something which is way too what? Too strange. We are simply talking about things whereby we even know. Okay. We are even talking about things which we even what? We even know. Guys, when you talk about Hooke's law, we are simply talking about what? Extension. We are simply talking about what? Extension. Okay. And to extend simply means like to increase. Okay. To extend simply means to increase. That's what it means. Now, guys, Hooke's law, it simply means extension. Okay. So this is extension. Okay. So now here, guys, let me try to break it way too down so that it's way too simple for you to do what? To understand. Okay. Now, guys, let us do this. Here, guys, under extension. In short, we are simply talking about what? Springs. When you just hear Hooke's law, we are talking about springs. Guys, how many know what a spring is? I hope almost every one of us have seen a spring. We all know my springs, right? We all know springs, right? We all know springs, right? How many knows my spring? We know springs, right? Yes, we know springs. Okay, we know springs, right? Yes, we know springs. Okay, we know what springs are. So here, it is very much essential that when you talk about extension, you try to understand this key thing. Here, we have a spring, which is like this. A spring is like this. We have a spring, which is like this. Then also we do have a spring, which is like this. You see, I want you to see the difference. Have you seen? So here, I have put a load, or be it something which is heavier. All right. Now, this is just the normal spring. I haven't put anything here. There's no load here. Then now here, if I put a load here down, if I put something which is heavier down, the spring it's going to do what? It's going to extend. That's what you call extension. You see, ati kudamfunuka. Yes, like what we say in Chinyanja, ati kudamfunuka. Yes, so kuja kudamfunuka, that's what you call what? Extension. You see, yes. So here, I hope we have gotten here, guys, what it means. I hope I have done my job here very well. Have I done my job very well here, guys? We have a spring here whereby I haven't put any load, something which is heavier. But if I put something which is heavier, the spring is going to do what? To increase, or it's going to do what? To extend, which means it's going to increase. You see, that's what we are talking about. Okay, that's what we are talking about. So the load here, if you check, if I put the load here, where this spring is going to end, where this spring is going to end, that's what you call what? Yes, kudamfunuka. That's what you call the elastic what? Limit. Okay? So this is the limit, you see, this is what you call the elastic limit. Okay? So the increasingment of the spring, we call it as extension. Where now it has ended, where it has reached now, we call it as what? Elastic limit. Because it cannot even go any further like this. Because if it goes more than this can end up what? Can end up, let me say, it can end up, how can I put it? Mm, this load can end up failing. All right. So now here, that's what you can simply say. Here, when I put a big load here, this key thing is going to extend. Then now where the spring is going to end, we call it as the what? The elastic limit. That's what you're going to say. All right. That's what you're going to say here. Now, here, after doing these key stuffs, it is very much essential for you to know something. It is very much essential for you to know something. Guys, we have what you call the original what? The original reading, okay? We have what you call the original reading, and also we have what you call the what? The recorded one, okay? We have what you call the original and also the recorded what? Reading. That's what you have to know, okay? Now let me try to break it way to down here. Guys, here the original, okay? When I didn't put the load here, let us assume that it was 10. 10 what? 10 centimeters. You see, upon not putting the load here on its normal state, it was what? 10 centimeters. On its normal state, it was what? 10 centimeters. But upon putting the load, it increased to be what? It increased to be 20. You see, it increased to be 20. You see, so this is the original. Then now this is what we have what? We have recorded. That's what we are talking about. So when upon not putting this key thing, the normal was what? 10 centimeter, but upon putting this load, it increased to what? 10 centimeter. This is the original, this is the recorded. Okay, now here, what you have to know. It is very much essential that you understand. You have to find the what? The readings. Okay, so the readings are very much essential for you to know. Okay, take note. Here it is very much essential. It is very much essential for you to do what? To know the differences. Okay, it is very much essential that you know the what? The differences of the what? Of the same reading. So here we normally say recorded, the recorded reading minus what? Minus the original. You see, so the recorded reading minus the what? The original. So the recorded one is this one, the one which we recorded, which is what? 20 centimeter minus what? The original one, which is what? 10. 10 centimeter, you see the way it is. So 20 minus 10, what is the answer? 10 centimeter. You see the way it is. That's what we are talking about. Okay, I hope something has been grasped here. I hope one or two has been grasped. Okay, take note here. We will be finding the same extension and also force. That's what we are talking about in this case. I hope one or two things has been grasped here under the same key thing. Okay, I hope one or two things has been what? Grasped. So this is how we get to find what? Extension. So this is extension. This is extension. So this answer is what you call what? Extension. Okay. So this is extension. This is how we get to find what? Extension. Okay. So here you will end up seeing this in a box. This is a box, right? You see this in a box. Okay. Then here they will end up saying reading. Okay. So this is the reading. Thank you very much. Reading. Then now, when it comes to reading, here they're saying that what? There is, let me say 120 here. Then also here there is 126. Then also here there is 132. You see, then now here they have said that, okay, find the what? You should find the extension. You see, find the extension. You should find the extension like this. You find the extension. You see, guys, so the first number you see, this first number you see, 120, this 120 which you see, the 120 which you see here, it is called what? It is called the original what? Reading. This is the original one. This is the original what? Reading. This is what you call the original what? Reading. You see, the first number here after reading, then these are the numbers. So the first number is the original one. Then these numbers which we are seeing are what? Are new what? Are new or rather recorded what? Recorded readings. That's what you are trying to say here in this case. Okay, now they want you now to fill in the box. You see, so how are you going to do it? Like what we did here, guys, we start first with the what recorded, the bigger number, then minus the smaller number. So here, since it's the original, we'll be doing what? Here, 126 minus 120, then 132 minus this key thing, okay? So we will be subtracting these numbers from 120. Okay, so you will start first from the first number. So 120 minus 120, what is the answer? It's 0. So you start first with the first number, this same first number. You say 120 minus 120, that's 0. Then you say 126 minus 120, it's 6. Then you say 132 minus 120. What is the answer? It's 12. Yes, it's 12. You see, so this is how you get to find the what? The extension in a box. Okay, so you go where there is reading. So these are the numbers you see. So the first number is the original mass. So what are you going to do? You start with the same original mass. 120 minus 120, it's 0. Then now, all these new readings, the bigger numbers, you must subtract them from where? From the original mass. So this minus this minus this. You do the same thing. Okay, have we gotten something here, guys? This is how we get to find the extension here, guys. I hope something has been grasped here. So in a box, this is how we get to find what? Extension. Is it hard? Is it hard to find extension? Is it hard to find extension, guys? Mhm. You see that it's way too simple, right? Thank you very much. And you know what, Wupe? You know what, Wupe and others? I get to explain, I get to explain, I get to explain so well because of the English language. You see, teaching English for a longer period of time, it normally helps in terms of explaining very well. So teachers who teach English a lot, they do explain very well, okay? Because teaching someone how to write a composition, teaching someone how to answer rewrites, you have to sweat. So no wonder explaining science, it becomes way too clear, okay? Very much clear. It's because of what? Teaching English too much. Yeah. So here, this is what we get to do what? To find. All right. So this is very much beneficial, guys. Very much essential. Okay. So here, this is how we find. And also here, there can be even a box. A box for this one. You see this? They can put another box. They do this. Okay. They put another box whereby it will be specifically, then they say for force. They can even add the other box for finding what? For finding force. Okay. For finding force. Then here, there is a box for mass. Okay. There is a box for mass. Okay. Then here mass, you see, like this. Don't forget for the readings, guys. So these are the readings, how to find extension. This minus this one, we get now to subtract everything from the first number. Okay. So now here, force. They want now to fill in the boxes for force. So what are you going to do? Let us assume that here, when it comes to mass, we have these numbers, okay? So we have 2, we have 3, then we have 6. They normally give you for mass is given readings is given. For extension and for force are not given. Force and extension are not given. So these are the ones which you will be finding, but mass given and the readings are given. So force, we all know that force is equals to what? Mass times what? Acceleration, which means due to gravity. Okay, that's what you have to know and also what? Understand. All right, that's what you have to know and also what? And understand. So here you have to be very much careful a bit, because here mass, take note, they can say mass here, which is given in what? In kg. They can give you mass which is in kg. So what you have to understand is that you have to change this mass from kg to grams. Okay, you have to change this mass, this kg to grams by dividing with what? With 1000. That's what you have to know. Okay, that's what you have to know. Okay, so here, what are you going to do? Here, they can do this. This mass is given in what? In kg. So kg is big. Okay, so kg is what? Is big. That's what you have to know. Kg, kg is way too what? It's way too big. All right. So what are you going to do? You must not get these two directly or exactly here. Okay. The mass here is in kg. Kg is bigger than grams. All right. So kg, no wonder we do buy a bag of millimil at what? 25 kg. Okay, which means it's way too big. All right. Most of the drinks, okay, or be it other foods, all right, packaging foods, they are, let me say, packed in grams, all right, the grams. Okay, be it if you drink that Camu kit, they are going even to show the grams inside, okay, because it's way too small. But for the kg, it's big. Okay, so no wonder here this kg, they are simply expecting you to convert these. Okay, so you must not copy and paste and put the two here. Your answer will be what? Wrong. So what are you going to do exactly here? You're going to say F is equals to what? Is equals to mass. You see, ka? This mass, you see, ka? It's in what? In kg. So you must not get this 2 and put it here. What are you going to do? You will be dividing these numbers with what? 1000. You're going to say 2 divided by what? 1000. Why? Because whenever you are changing grams to kg, we divide by what? 1000. That's what you should do. But here, if they put grams, you just copy and paste exactly, because grams, it's small. Kg, it's big. You see how tricky they can be sometimes here, ka? They even put these numbers, okay? Okay? They just want to see how smart you are. Because if you see grams here, you see that it's way too big. So which means you must change it. All right. So how are you going to do it? So these 2 divide by 1000, you see? Also here, 3 over what? 1000. And also this 6 over what? 1000. Like this. Okay. This is what you should do. Okay. So here, 2 divided by 1000. If I'm not mistaken, guys, isn't it 0? Isn't it 0.2? It's what? Yeah, something like this. 0. Yeah, 0.002, yes, times then acceleration due to gravity. We all know that it's 10 Newton per kg. We all know. All right. So here, 0.002 times 10. Then if we do times, guys, what's the answer? Those who do have calculators, mine is kind of far, sorry. Those who do have calculators, those who do have calculators, yes, help us to do 0.002 times 10. Take note, guys, calculators allowed here. What will be the final answer? Okay, see, 0.02, which is in what? In Newton, like this. You see? Then also here, you continue with the same thing, 0.0 what? 0.02, like this. Also here, you do the same thing, 3 divided by the same thing, then here you do times, you fill here, and also here you fill here. Okay, this is how you get to do what? To fill in the box. Guys, don't forget from the reading. This is the original mass. This minus this, 0. Everything minus this, everything minus this. Then for the force, don't forget, if you see kg here, what should you do? Convert it. The numbers which are in mass here, when finding here, make sure that you convert them, all right? 2 over 1000, 3 over 1000, 6 over 1000, because we are converting from kg to what? To grams. Yes, guys, you can continue like that, you fill. Okay, you can fill in the box. You can fill in the box. Okay. All right. Perfect now here, guys. Perfect. Perfect, 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 perfect. Okay, so now here, guys, that's how you get to do this key thing. Now here, you have also to know how to state Hooke's law. You have to know how to state Hooke's law. What does Hooke's law states? Guys, like what I said, here we do have a spring, which is like this, and also a spring, which is like this. Okay, so this is spring, it has been extended, then this is the original one. You see, now what does it state? It states that what? That the extension, okay, it's like this. Okay, when you see in the box, they will put something like this. You see, they are going to put something like this in the box. When you see mass, then kg. Kg is big. You have to convert the mass which is given. You have to convert these masses from kg to grams. Like for example, here you have a 2. Okay, they have given these numbers for you. In the table, these are the numbers which they have given to you. Whenever you are finding force, you must not copy and paste exactly these numbers the way they are. What should you do? We know we want to fill the box of force. So force is equals to mass times what? Acceleration. So you end up saying force is equals to mass. Now, the first mass is what? 2. You must not write 2 here because this 2 is in kg. You have to convert this kg to grams so that it becomes smaller. So changing kg to grams, we divide by what? By 1000. So all these numbers we have to divide with what? With 1000. That's what you should do. Okay? That's what you should do. You see, so we end up saying 2 divide by what? 1000. Then also this one, 3 divide by what? 1000. And also that other one, 4 divide by what? 1000. Like this. So when you divide, that's where now you can write your answer here. Then times 10. When you divide, that's where now you can write your answer here times 10. Then you fill the box. That's how you fill it. Okay, but when it's grams here already, you just copy and paste exactly because it has been deduced already for you. So Hooke's law. Hooke's law states, so it states that the extension, it states that the extension, which means the extension which comes from the what? From the recorded what? A spring or rather reading. So it states that the extension, okay, the extension of what? Of a spring. It states that the extension of a what? Of a spring, okay, is proportional. So the extension of the spring is proportional to the load, okay? Or in short, it depends to the load that it carries, okay? States that the extension of a spring is proportional to the load applied to it. And that's true, okay? Because if you put a load which is worthy 20, let me say, kg, all right, there will be a certain limit whereby it's going to stop, okay? So it states that the extension of a spring is proportional um, to the load, it is proportional to the load applied to it. Okay, so applied to it. Okay, take note, provided that the elastic limit is not exceeded. Okay, where it ends, it must not what be exceeded, provided that where it ends. Okay, provided that the elastic, so provided that the elastic limit is not what is not exceeded. That's what it means. Okay, exceeded, that's what it means. You see the way it means, huh? So here, when I put here, like what I've explained, just you see, huh? So if I put a load here, which is worthy, let me say 200 kg, you see, huh? So here, where the spring ends, here, where it has reached here, that's what you call the elastic limit. This is the elastic limit, which means it must not be exceeded, which means it must not be increased or extended as well. It must stop here. Okay, it must stop. Okay, so take note, this distance from here up to here is what you call extension. So the extension here, which means the part from here up to here, is what you call what? Extension. Okay, even if we have extended, take note that this elastic limit must be what? Must be not exceeded. Okay, so it states that the extension of a spring, is proportional or is proportional to the load it carries or applied to it, provided that the elastic limit is not what? Exceeded. That's what it states. That's what we are simply what? Talking about this key thing. Then also, aside from this, they can also ask you to differentiate between elasticity, in short, which means elastic. What is the difference between elasticity and plasticity? Okay? Elasticity, which means elastic, then now plasticity, which means plastic. So this one, it can be reversed. Yes, if you do elastic like this, it can be what? So this one, it can be what? It can be reversed. But this one, it cannot be what? It cannot be reversed. We cannot reverse a plastic, all right? So elasticity, it is what? Reversible, but this one, it is not what? Reversible. That's what the difference here between the two is. Okay, they can also try to ask you this kind of a what? Of a question. Okay, also the graph here, it comes out straight. It can come out straight like this. Okay, can ask you, has the graph obeyed Hooke's law? Yes, because it is moving in a straight line. All right. Also here, it comes out straight like this. You see, so we are forming the graph of force against extension. They're going to ask you, plot the graph of force against what? Extension. This is how it kind of looks a bit. All right. Hooke's law is so interesting and way too simple. You just have to know how to find force, but make sure the mass provided must be in what? In grams. So if it is not in grams, convert it, change it. All right. That's what it is. So guys, I think I've helped now. I think I've helped a lot. All right. So I will be saying my goodbyes now. I hope I've helped one or two. All right. I hope I have helped one or two. Okay, thank you very much. Okay, Whoopi, you're saying much time tomorrow. It's like you guys, you fear physics, you fear chemistry, right? you fear chemistry, right? Sorry. Oh, concerning the part of tomorrow, I will be live exactly 15 hours, 15 hours, and also at 21 hours, we'll be live. Don't fear chemistry, you're going to enjoy it. I'm telling you the truth, you will enjoy it. All right, you will enjoy it. So guys, thank you very much. Don't fear graphs, guys. Don't fear graph papers, all right? And I really hoped that we would have started long time ago. If we would have started long time ago, if you guys you had joined my WhatsApp group, if you guys had joined my WhatsApp science group, you would have enjoyed, because your friends, as they will be sitting for their final exam tomorrow, they are so prepared. Okay, so all those who are under my WhatsApp group, okay, they have benefited a lot. So as for tomorrow, they're even sleeping as for now. They're even sleeping as for now. You see? So if you were with us, guys, you would have benefited a lot. All right, very much. Okay, so guys, I will do as wise tomorrow. I will do as wise tomorrow. So thank you very much, guys. I will be saying my goodbye. Thank you, thank you, thank you, thank you. Thank you. And don't forget to subscribe, guys. Don't forget to subscribe to this YouTube channel. Don't forget to subscribe. Guys, wishing you the best, wishing you the best, wishing you the best, guys. Wishing you the best. You are going to do it, guys. Make sure that you just stay calm, okay? Start with the things that you know, all right? Make sure that you start with the things that you know. Start with the things that you know. Start with the things that you know. Otherwise, if you won't start with the things that you know, you will get stuck, all right? Chances are there that you will get what? Stuck. Okay, so start with the things you know. So thank you.